Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, and welcome to the Digital Enterprise Society podcast. Thank you so much for choosing this podcast, because there's over 2 million podcasts that you could be listening to, and yet here you are at the Digital Enterprise Society podcast. And this is the show that is designed to be a resource for those who work in and around PLM. The Digital Enterprise Society is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, visit digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, here we are again.
Yes, we are. Hey, Thom, it's good to hear your voice, and I'm looking forward to the discussion today. I was recently at a conference, it was all virtual, unfortunately, that SimData hosted, and one of the speakers at that conference had an interesting series of points about systems, and that's all I'll say. We'll get into it here in a little bit, but I thought the audience might like to hear more about systems because it's on everybody's mind as we talk about complexity. And so today we're going to go a little broader than just PLM. So there we go.
Nice. Well, as always, we're always on the lookout for great guests who are going to bring to this podcast interesting interviews and points of views that are going to help all of our listeners enhance and grow their career. And today we are joined by Patrick Hillberg. Now, Patrick is an adjunct professor at Oakland University in Michigan, where he teaches a class about product lifecycle management. He's also an avid writer and speaker on that topic, and he used to be a lead architect at Siemens, and he was the U.S. lead for their academic and workforce development group. So, hey, Patrick, thanks for joining us here on the Digital Enterprise Society podcast.
Oh, thank you so much for having me. This is loads of fun. I really enjoy doing this sort of thing. And yes, it would be great to be together, but quite frankly, I think we can do more. It's a less deep engagement, but we can engage more often now that we're doing this via Zoom. So.
Yeah. Well, it's interesting because I've been using Zoom for 10 years for different things that I've done as a speaker, a trainer, a podcaster. And in the last 2 years, I feel like many of us, I feel like I live on Zoom, and I don't know what we would have done if this whole situation had occurred a decade earlier when we didn't have this ability to be able to use these great tools to be able to stream and connect. However, I will tell you, as a person who speaks and MCs at live events as part of my career, I do miss having, a weekly trip to a different conference to be able to interact with people. But, it is what it is. And, here we are in the podcast world, which actually, is always just coming in via audio. So, Patrick, tell us a little bit more about your background than what I was able to say there in that introduction.
So, yes, thank you very much for the introduction. I began my career writing software for robots back in the 1980s. So I was developing software, living in factories. I still have steel-toed shoes and a hard hat and all that sort of stuff. Although, much of that work actually has now, and because of the PLM technologies, much of that work has virtualized and it has all moved up into office spaces. So, and I kind of saw that coming in the late 90s. And then actually Daimler Chrysler, it had that name at the time, had a PhD fellowship that was made available to me. So I, at that point, had an undergrad in computer science and a master's in industrial and systems engineering. I took the fellowship in order to go get a doctorate in systems engineering, and then moved on from there. And I've maintained that connection with Oakland University throughout all this time. So really beginning with my first class in 1994, and now I teach at Oakland University. And I've been back and forth throughout my career through that whole thing. Maybe 10 years ago, the head of my department, Bob Van Til, who was also my PhD committee chair, decided that he wanted to build a PhD program. I'm sorry, he wanted to build a new department within the university around the idea of PLM. I created the first class there called Product Lifecycle Management, and it's pretty much what you would expect from a PLM course, or it was what you would expect from a PLM course. We covered a little of the technology. We covered change management. We covered product data management, a little bit of CAD and that sort of thing. So in the past, and then I'll say I built the course out of a book that from an author that you guys are familiar with, Mike Greaves. So his book, Virtually Perfect, had come out just a little before I started teaching that class. Originally, the class actually was Mike has 15 chapters in his book, and I had 15 weeks to teach, and every week we read a different chapter. Mike really opened up my eyes, actually, in terms of product lifecycle management, and what I now refer to as managing product life cycles, because I make a separation from the PLM technology. But there's a big business need around managing product life cycles. And whereas I originally came in talking about, the CAD stuff and the database stuff and that sort of, and workflows and that sort of stuff, I really moved the class much more towards the business aspects of PLM. And I just developed a lot more interest in that. So.
Well, Pat, thanks for joining the show. You and I share a past with Mike Greaves. About the same time his book came out, he was advising us at Powertrain for General Motors. And so we were only a few blocks away because we were located over in Pontiac, right? Mike's way of structuring what product lifecycle management should be, and his title of his book, Virtually Perfect, it did a really good job talking about, well, the purpose of it all is to be able to make better decisions earlier and not rely on physical prototypes so much, right? Which is the legacy of any industrial company of the last 100 years. So anyways, one of the things that frustrated me as I became the PLM leader about a decade ago was this point about there were way too many different definitions of PLM. And so I thought, you're a professor, you've thought about this as long or longer than I have. Define for our audience what PLM is, and in particular, the importance of the words, which we tend to ignore when we use all these acronyms. So what is PLM?
Yeah, thank you. So, I actually have two definitions of I rearranged the words. So I think if you asked, I think 90% of the people who are familiar with the phrase PLM would refer to the technology. And a lot of that originates out of CAD. So 90% of the people will say, well, PLM is the technology that manages our CAD. And of course, that's pretty much what product data management is too, PDM. So PDM then expanded out into the larger areas. But if you look at Mike's book, Virtually Perfect, and also John Stark's books, Mike has 4 phases to the product lifecycle: create, build, support, and dispose. And John has pretty much those same 4 phases, but he has an ideation phase that occurs before create. And ideation gets to what's the financing and what's the organizational culture and structure and those sorts of things, which have big impact on the product lifecycle. So the PLM technologies, they can manage your requirements. They can manage your CAD. They can create part numbers for you. They can you can handle changes and all that sort of stuff. And they can even design the factories that will build the product. But they don't record the data on how the product was built, and that really gets to another data. So that would be in the build phase of the product lifecycle, and that's a different technology, which is either MES, Manufacturing Execution Systems, or MOM, which is Manufacturing Operations Management, I think. And then there's a support phase. So how often does the car come back into the service bay to be repaired? So, and there's one-to-many relationships between those. So one design can create many cars, and every each individual car can be serviced many times, and there's just different databases around that. So the first definition of PLM is the technology. The core definition tends to be the technology that manages CAD, and then we can expand into all the things which influence our design and even design our manufacturing system. But there's still the MES to manage the manufacturing data, and there's still the MRO to manage the service data, and that's PLM technology. But I had something else in here, and actually what I now teach in my course, I call managing product life cycles. And that's just, and so MPL just kind of separates itself from PLM, and we don't discuss technology in my course. We talk about all the cultural aspects and the organizational aspects that have an impact on the product. And we can get more deeply into this. I'll just go on and on and on if I don't. But just briefly, how we build a product is heavily dependent on how the organization which builds that product is structured.
Right.
And I think we're particularly seeing that now as our products become more autonomous and mechatronic, meaning we need the electrical and the mechanical and the software to all work together. But that there's a mechanical group and there's an electrical group and there's a software group within the organization. So the product that we come up with becomes heavily dependent on how is the organization structured to allow collaboration between those groups.
So this is interesting. So because this is part of the problem I had is I would talk to the PLM experts as I became more interested. Now I have an aerospace degree and a controls background. So the mechatronics thing, I lived and breathed my 40 years in the business, right? And so I get to these mechanical guys who are managing CAD, who are driven by the investment in a factory. So I like the way you described, you build it, right? But in reality, the point about managing requirements, well, the trouble with requirements is, especially at a commercial company, is we don't really know what they are. We don't know how people are going to use our products. And so you talked about manufacturing operations. Well, if you get even into the service world, you find out not to repair, but more to understand what the customer does with the product. It's really interesting to me how PLM has really missed the boat at that. And I think this leads to something that you and I both talk about, which is systems engineering. And it's really easy to talk about, but the trouble is it's also really, really amorphous or vague.
Yeah.
So I want you to talk a little bit about your point on system engineering and why it might be a misunderstood skill. And I'm interested in your perspective, especially since you have a degree in it. So you should know the answer, right?
Yeah.
As if there were one answer.
Oh, it's interesting you bring that up. I have a master's, a doctorate, and a faculty position. All have the word systems engineering, and I don't know what it means.
Well, okay. So then that just means you're truly an academic, right?
Yes, right. Exactly.
You get to debate it. But for a moment, I still want your perspective. What is system engineering?
Sure. So our products are so complex, and actually I'm going to get into the difference between complex and complicated, but our products are so complicated. There's so many moving parts. There's so many different organizations, so many different individuals who are all involved in this. And we certainly need to manage requirements. So I think most systems engineers spend most of their time, right? And most is a vague word, but a lot of systems engineers spend a lot of their time managing requirements. And how do we do that? And how do we realize that some requirements may conflict with other requirements? So I definitely, my class suits both engineering managers and masters in systems engineering program. I get a lot of systems engineers in my class, and that's what we get to. So there's some new technologies. There's model-based systems engineering, and there's SysML, and these things allow us to start recognizing the interactions between different pieces, and that's really important. And that allows us to manage that information. And to tell you the truth, PLM, the way the databases in PLM are structured, being object-oriented databases, and I know you've talked about that in previous podcasts. The object orientation of the database allows for those connections to be made, that there's not just a part sitting in a CAD file sitting on a file system. Why is this part here? What are the requirements which led up to the design of this part? how do those requirements interact with some of the other requirements, so that we can build kind of we can build a more comprehensive view of these complicated products that we're developing. There's an aphorism I heard about an airplane, that it's not so much an airplane as a million parts flying in closed formation. How do we manage all those parts? How do we make sure that they're really connected? And how do we understand that, what's the one I saw recently? 5G may impact the communication systems on an airplane. So that's something that's, I think, currently.
Yeah, there's some frequency issue there around an airport, I think. But that sounds like I know what I'm talking about, but I may not. but okay, so we have complicated systems. I like the way you said that. And then systems and product, I think a lot of people assume are the same thing. They're synonyms, when in fact they may not be. And let me give you an example. So systems in a commercial products company are the broader systems, especially if you have regulations like fuel economy, like the car business does, right? At least for gas engines, right? And so the system boundary keeps changing, and managing requirements across many products, because you get measured on fleet, corporate average fuel economy for the fleet, yep. Right? Mm-hmm. And so people come up with these models, systems engineers comes up with these models that say, well, if you sell big trucks, you better sell small cars because you have to offset, right? And so it gets really complicated in a hurry. Now, it should be the case, and you were going there, where PLM and SE should help each other, right? On the other hand, maybe there's still something missing. And this complication due to regulations, some people would argue, well, that's just another requirement. Yeah, but it's across multiple products. I mean, you're making choices in your product strategy, your product lines, in order to manage those kind of requirements. So what's missing? I mean, you've mentioned a couple of these other things about operating in a factory and planning manufacturing, which is capital intensive if you're making physical parts, right? There's a whole world of mechatronics, which is enabling changes anytime. It doesn't have to be at the point of manufacture. It could be as you put it in your driveway every night, right? So I'm curious. There's something missing, and I'm curious what you think that is.
Yeah, actually, I'm going to give an analogy, and I teach this analogy in my class, and I apologize because I know, Craig, you're from GM, and this was a scandal at GM. However,
okay, you realize I can't talk about certain things, but keep going.
Course, no, absolutely not, absolutely not. So in 2014, actually, I was at not GM, it was a completely different customer site, but that week the ignition switch recall had blown up in the news, and the CEO was testifying to Congress about failed processes inside GM, and the engineers at this completely different customer commented on or decided that they would continue to follow the same failed practices that the CEO was apologizing for. And that's where I really said, I flew home. I was teaching the class on the weekends at that point, and I flew home and I told the class, we're going to talk about the ignition switch. And the reason I'm bringing this up is, if you look at the larger system on that, there was a new governmental requirement about disabling the airbags when the car was sitting in a driveway, because we don't want kids playing in the front seat unintentionally inflate the airbag while they're just playing in the driveway, right? And then there was so that was a high level requirement, and then there was a software team that decided to implement the requirement, and the way they implemented the requirement was to only power their system when the ignition switch was in the run position. Mm-hmm. And then there was a person responsible for the ignition switch, and he didn't know that the airbag had anything to do with the ignition switch that he was working on. And very late in the development process, so late that it would have delayed the launch by months, he realized that there was a tension problem in that spring. So I think actually now there are technologies to address that problem. There's A-Spice, there's ISO 26262. Did I have too many in there? 26262.
No, you got it.
Yeah, okay.
3 and 2.
So if and I take my class through this, and actually that engineer had a position called a design release engineer, and probably a third of my class are DREs. And we've learned a lot of stuff. They learned from this, and they've always also have taught me a lot about the design process. But what we go through in this case is that there was a new requirement. There was a team there was a team that made a decision about that requirement, but did not communicate the impact of their decision across the overall system, all the engineers who were involved. Then there was an engineer who was faced with a strong ethical dilemma of, the spring is not holding tension, and I'm going to have to delay the launch by months. Mm-hmm. I asked my class, what does it mean if you're late on delivering a product? And their answer is death, meaning figurative death, but nobody at this point realized that there was actual literal issues going on. So there absolutely are some technological things that have been developed since that problem originated in 1997 that are being dealt with the PLM technologies and ISO 26262 and ASPICE and the AutoSAR. That's another one, right? So, but we still need the human. I think the human system is the thing that systems engineering is missing out on. Are we recognizing the impact that humans play?
Well, and humans under pressure make choices, right? And so one of the things I hate about bureaucracies we've all dealt with in our lives is, an edict comes down, we need better fuel economy. Well, how are we going to do that? Well, everybody's going to lightweight. Everybody? Well, yeah, everybody. Well, let's go after the big parts first. Well, wait a minute, some of those parts protect you in a crash, right? I'm thinking of the fenders, right? And so part of the culture, back to your point about the people, well, if you're told your job is to reduce 10% of the mass of the part, lower material will cheapen it a little bit, and of course it'll be lighter. And if it's lighter, then we can go further on a quart of gasoline, right? So the system there is the decision-making process, right? And this is, the PLM guys. I'm glad you were at one of them, or actually a couple of them. When I would deal with them, they're like, "Oh yeah, isn't this great? Look what our tool can do." And I'm like, "Yeah, but who would use it in the company?" You're missing the point about how do you roll out the use of this better technology, this better tool, to a particular role in the company. The company doesn't have the role. The system engineering side of it, there's some of this is Detroit folklore for everybody else listening, but system engineering, especially as that problem you mentioned came out, people will encourage, you got to know how your system works 2 interfaces away, was what one of my leaders used to point out. So it's your job. You need to know. You don't wait to be informed. It's your job to go find. And so this led to a lot of people embracing design for Six Sigma, which, by the way, I'm a big advocate of. But it's a systems engineering technique, right? And it just gets really complicated if you go across multiple products. So you introduce this term, and other people have too, especially industrial designers, about systems thinking. So what is systems thinking, and how does it help this problem that we're talking about?
Yeah. So thank you, because this has become a big passion of mine, is to expand beyond systems. And I see that both systems engineering and systems thinking are necessary, and they're kind of I'll talk about this, but they're on they're on 2 axes. There's a systems engineering axis and a systems thinking axis. So
to be clear, they're not the same thing.
They're not the same thing, and they're not. One's not an extension of the other. So, thank you. Your original question was, what is systems thinking? And it a little bit depends on who you ask. I follow I'm a good academic, right? I follow 2 textbooks. One is The Fifth Discipline by Peter Senge, and the other is Thinking in Systems by Donella Meadows. And the 2 authors knew each other, and they actually refer to each other in their books. But I'll stick with The Fifth Discipline right now. One of the core concepts is the concept of feedback loops. So you have a reinforcing feedback loop in which a little bit of growth increases the likelihood of growth. And currently, of course, we're all talking about viruses and pandemics. So as a few people get sick, they can get a lot more people sick. And as more people get sick, we get a lot more people sick. So that's reinforcing growth. Balancing feedback loop is growth will discourage growth. So the thermostat in your house is a case of a balancing feedback loop. So when the house gets too warm, then the thermostat will say, hey, it's too warm in here. I'll shut off the furnace, and then the house is allowed to cool from there. And then Senge gets deeper into, he claims that systems thinking is the fifth discipline, and the first is personal mastery, and then let's see if I get this, personal mastery, and then mental models, and then shared vision, and then team learning. And you need to step yourself up into that. So, it's one step and then the other. We're very strong on personal mastery. Our schools are very much based on the idea of teaching personal mastery. If you look at the systems engineering techniques of decomposing very complicated things into small pieces and then training people so that they're experts and they're personal masters in their small pieces, that's kind of where we are right now with systems thinking. On the other axis, we need to start bringing in the other stuff. We need to start looking at mental models. So it's not just your mastery of a topic, but your mental model of what you think is important, that will just make your decisions. Beyond that, then there's shared vision and team learning. And the way I run my class and the way I used to run projects was very much based on team learning, which fits nicely into Agile. And I know you guys have some other podcasts on Agile, so you go deep into that. But
so let me slow you down just a
sure.
So you were talking about discipline and decomposition, and I think you said systems thinking, but that's really systems engineering, right? The evolution of systems engineering. Systems thinking is what brings in this teamwork and this constant feedback, which just, it all makes sense when you think about it. I mean, the Google guys, when they formed their company, and now they're one of the biggest companies in the world, right? That was all about, and we don't trust anything without data, without feedback, right? This point about continuous feedback, and so I think this is where big industrial companies that make things out of raw materials like iron have really struggled with, well, how do they become a Google-like, right? How do they become constantly aware? And mechatronics, to the credit of all those people involved in that, have now made it possible to do continuous upgrades. Oh, well, if you're going to do continuous upgrades, you better be system thinking. And it's not just your company's success, but it's your customer's success, right? This collaboration, coexistence of people willing to pay for something versus people making it, they've got to be in the same systems. They got to be thinking the same way. So this is interesting. I like the way you describe it, constant feedback, because that's where we sometimes don't understand. So, okay, so this is why systems thinking is better than modern systems engineering, right? Is the ability to have this constant feedback. What I would guess maybe students today actually get it. It's us older guys that have the problem where we were trying to we did decompose and tried to optimize the manufacturing line, right? Because somebody said it was too expensive or it was too weighty in my other example. So I guess do you see the system engineering community like the guys at Incosi? Do you see them embracing systems thinking? This world where we have constant feedback?
That's an interesting question right there. Actually, I'm going to give kind of two answers. First, going back to a little bit to what you said about younger people and students, I've learned I give everybody an A in my class, and I tell them the first day that everybody gets an A in my class. I put them into positions where we constantly talk about what they are working on. So they don't give homework to me. They post their weekly homework to an online forum where they can learn from and respond to each other. So
this is like continually transparent. This is good.
Yes. Yeah. I should also tell you, at the end of the semester, my life gets really easy because I don't have to grade, and I don't have students coming to me saying, "Oh, can you please give me a better grade?" But so I'm really big on that, and I don't want them to feel responsible to me. I want them to feel responsible to each other, and quite frankly, they they do far more when they're when they're trying to impress each other. They do far more when they're trying to impress each other than when
That's
they are trying.
Insight.
Yeah. Oh, I get so much more out of them, right? So, and I've heard the same thing I ran Agile. I love Agile, and I've heard the same thing from other people who are using Agile. That boy, suddenly the handcuffs came off. Then I had a second thing I was going to say, and now I've forgotten what it is.
Well, let me take it to complexity. So a lot of us are talking about complexity. The trouble with PLM is it's all about product or parts or managing CAD files or managing capital for a factory. And it really needs to become this managing the life cycle of a product, right? Which you pointed out at the beginning. So how will systems help complexity going forward?
We really need to look. So my definition of complexity is, my definition of complicatedness says you can manage it in systems engineering. My definition of complexity says you must include systems thinking.
Oh, wow.
Which includes,
that's good.
Yeah. and I kind of reversed the definitions around a little bit, but I made the definition fit my solution, but which really gets into collective learning and shared vision and those sorts of things. So to deal with complexity, we have to deal with the organizational structure that is building these products that we want to build. And then let me kind of finish up with this is, I don't think it's possible in an infinite sense to manage complexity. I think we need to reduce complexity. And we really need to look for ways to do that. So.
And when the complexity is caused by stupid edicts about everybody lightweight 10%, we ought to have the data that says, you really don't want to do that. You really want to understand, things like failure modes. And so you get hazard analysis and safety standards. And you've mentioned a lot of those. Well, Patrick, this has been fun. Yeah, you and I are close to each other in the Detroit metropolitan area. And I think we should talk more about other PLM topics, and I'm sure we will. Thom, back to you.
Yeah, Patrick, thanks for joining us here. This was a great conversation, and we would love to have you back.
Oh, I'm looking forward to it. I would greatly like to be back. I'm very passionate about the Industry 4.0 workforce, and I would love to talk about that sometime.
Making them want to work together all the time, right? That's how we reduce complexity. Or something like that.
Well, again, thank you to Patrick, and thank you to everybody who tuned in and listened. We'd like you to join us every single week for more thoughts, ideas, and information in and around product lifecycle management. Remember, the Digital Enterprise Society is the place for the exchange of ideas around digital manufacturing tools. Go check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.